Okay, welcome to the second part of the one pipe radiator pitch experiment video. Should be the last part. And I've just started up my system with a long call for heat, and I'm letting steam travel through my flexible appliance connector, and you can see it's down there by the valve now. Is where I believe the heat is. Let me make sure. Yeah, it's just getting here. You can see, if I zoom in here, you can see some condensate starting to collect on the on the sight glass. And steam's just getting in here. And if you recall from the last video, we saw I tilted the radiator downward in this direction, away from the supply pipe. Oops, trying to keep two cameras aimed here at the same time, and one of them's in a tripod and one isn't, so it doesn't go great. So it's tilted away from the supply, which means it's tilted in the wrong direction. And last time it worked fine. Condensate filled this corner here and along the bottom, and until it started to run out the valve, just like it does on any normal one pipe radiator. And there was no problem with anything. The vent didn't give me any trouble. I just can't imagine why the vent would give me trouble in this situation. You know, the vent's right here. You can see it right there. It's a Hoffman. Only if the condensate was stacked all the way up to the vent port could there be any problem with the vent, in my opinion. And we know that I was tilted like an inch. I'm tilted like an inch or a little bit more than that across the top of this radiator, so there should be an inch or a little bit more of condensate at the bottom over on this side, and then really no extra condensate on the valve side, because that's where it pours out of the valve and goes into my bucket here. So, but the problem with that was when I started running it, there was no significant water in the radiator, right? From the angle that I had set up. It was level when I set everything up on it, so there was no extra water. But now there should be extra liquid water at the far end of the radiator, the low end of the radiator. And I want to know if, as the steam enters this radiator, so let me step up here and show you what I'm talking about. As the steam enters the radiator, it's going to kind of want to tend up toward the top, and then it'll come back down again toward the vent. But once it gets totally full of steam, which will eventually happen, I want to know if the steam hits this cool condensate that's at the bottom of this end. You know, all these sections have liquid water laying in them now, more than they would normally on a radiator that's tilted in the correct direction. So if the steam is hitting those, is it going to cause any banging or any hammer? Or is it... Oh, my camera freaked out. Oh, there it goes. I don't know. Sorry about that interruption. Obviously, this is amateur hour here. So, yeah. Okay. So, as the steam does reach to the bottom of this radiator, is it going to cause any hammering or banging when the steam interacts with that cool condensate? Because down here we can see the temperature is like, there's 59 on my back wall. This wall is like 57. So it's around 60 degrees probably in here. It's warming up a little bit, but this radiator has been sitting ice cold for a couple days now, in my basement, and so it's in a range of 60 degrees probably. And so when the steam makes contact with that cold condensate at the bottom, is it going to cause hammering, or is the condensate that's running, the condensate that's running down here, is it going to mix with that cool condensate at the bottom, and is it going to, make the hammer, there's not going to be any hammer as a result of that condensate being warmed up, right? I could kind of see it going either way. And, it may be that the hammer really only tends to occur when the steam is flowing across a pool of cool condensate in a pipe, right? Like in a saggy spot in a pipe where the steam is flowing across the top of it, and it collapses when it's right there next to on top of that water. I don't know if that's going to happen in this radiator or not, but we'll figure it out and we'll see. I'm gonna just let the video run, and I'll edit out all the parts where nothing is happening. But for right now, this is what's happening. I'm like 6 minutes into my video recording, which was, I started recording when the steam started to get into the system. So that gives you some idea of how long it's been running. Something like 10 or 15 minutes, something like that. Because I was away for the weekend, so I had everything cooled in the house down to 60 degrees or so. So it's just now heating back up, and we'll see how it goes, and I'll be back. Okay, just checking back in. I'm now at 17 minutes since I started recording, just for reference, and you can see some heats coming into the radiator now, including at the bottom, which I believe is mostly condensate. Now, I don't know if, when these are running, when radiators are filling, and the steam, starts to condense at the top and condensate runs down to the bottom, it's going to have some heat in it, right? Does that make it easier for the steam then to go down that path? Does the steam, does it heat more quickly then, like this part down here, and then that leads it to, condense there and cause a local low pressure zone so that more steam is pulled into that area? Or am I strictly seeing condensate here, this bottom part? I don't know the answer, but my main goal here is to see if there's anything weird that's going to happen from this radiator that's pitched in the wrong direction. Oh yeah, I forgot to say, I'll put a floating link on this video to the first part of this video. You should watch the first part of the video before this part so you know what's going on. But this should be the shorter video by far, so just to let you know, I tilted this radiator the wrong direction, set it up as a one pipe situation, and ran it in the last video from dry, okay, with nothing negative occurred. It just filled up with steam completely. It ran perfectly silently. I never had any problem. The hammer that was in that video was from the steam pushing its way out of my water seal that's in my bucket at the bottom there. There was no hammer from the radiator itself. And I'm refilling now the radiator again with that extra condensate sitting in it to see if there's going to be any negative effect from having this radiator pitched really quite dramatically in the wrong direction. I mean, this is beyond what you'd ever see in someone's house. It's an inch or more lower on the far vent side than it is on the near valve side, and you're just not going to see that in someone's house. But just in case you do, we're doing this experiment to see if it's actually the cause of any trouble, because we hear people say a lot, the radiator shouldn't be pitched in the wrong direction. it's one of those common sense things, really. Like, obviously, you wouldn't want it pitched in the wrong direction. You'd want the condensate to be able to flow out. But we're testing just to see, well, what if it was in the wrong direction? Is that a big deal or not? And we'll see if we hear anything, or if anything starts happening as this steam fills the rest of the radiator here. It's got a ways to go. It's approaching halfway full of steam, so I'll be back again later. Okay, so we're getting the bucket problem where the steam is pushing down over here. The steam is pushing down the water column of the bucket, and so the steam is entering the relatively cool bucket, and that's causing collapse of the steam in that bucket. But that'll quiet down pretty soon, and we'll be able to see if there's any. I'll keep listening too to see if there's any hammering happening in the radiator. Maybe I should have put a trap down here or something instead of the water seal. I don't know. But either way, I'll be able to tell the difference between the hammer happening in the radiator and this hammer that's happening down here in the bucket. Because my pressure did get up to, well, right now it's about 9 inches of water column, and that's deeper than my bucket. So I'll let the radiator keep filling up with steam, and I'll listen carefully to see if there's any hammer in the radiator. And if there is, I promise I'll record it and tell you about it. Okay, it's like 37 minutes into this recording. And the radiator continues to fill with steam. It's funny that second to last section, it looks really cold in the camera here, but it's about 125 degrees over there. See if I can make it show us. Yeah, there you go, 125 degrees on that section. And it's cooler, seems to me, because there's no way for the steam really to get to this bottom one, because I believe the condensate level is above the horizontal port that runs across the bottom here. So consider this second section here is basically flooded at the bottom. The first section is flooded at the bottom too, but it has the vent. It has the vent to let steam into that first one. So that's why the second one here is not heating as much as the others. But these other ones are quite warm at the bottom. Let's see if I can get it to show us how warm. 200 plus degrees. So there's steam on these sections right here, all the way from top to bottom. And it's touching the condensate that's in there from last time. And I didn't hear one peep out of that radiator. You heard a minute ago the bucket was still making noise. It's not at this moment because my cycle guard has kicked on to check the boiler water level. But here you can see the bucket is getting pretty warm. It's looks like it's 160 degrees, 150, something like that in the bucket. So the steam is less violently collapsing in the bucket now. But I never heard anything from the radiator, not one peep. So I'm going to let this run a little longer, but I'm about to wrap it up and just say the pitch of the radiators doesn't matter. In one pipe or two pipe, it generally doesn't matter. Now, if you have a super long, like 8-foot radiator or something, or if you have a convector that's really long and just has, the single pipe running horizontally through it, yeah, of course it's going to matter more in those cases. But generally, if your radiator's anything close to level, there's no improvement you're going to have by putting checkers under one end of it or the other. I'm saying that. So if you want to run an experiment and show me the hazards and disasters of having a radiator that's pitched in the wrong direction, then by all means go for it. But right now I'm seeing no negative aspects from this radiator being pitched heavily in the wrong direction in a one pipe scenario or in a two pipe scenario. So that's where I'm landing on this. And this is going to be the end of the video. If this video continues after this, then you'll know that I got some new data. It started making noise or something. But if this is the end of the video right here, then you can know that I never heard this radiator make another peep. I'm going to keep running it, but I'm not going to bore you with more footage of me talking to myself. So that's it. Radiator pitch is not a big deal. All right? I'm putting it out there. I have to correct myself here a little bit. I just realized something, right? So this radiator, it's, what do you call it? It's really a hot water radiator, right? Because it's got a passageway across the top and it has a passageway across the bottom. So, or you might call it a hybrid. I don't know what you call it. But this radiator is fine. Now, unfortunately, I don't have a small radiator handy that's strictly a steam radiator where the only passage is on the bottom. And it's too bad because I would like to do that test, because I think that would cause trouble if the radiator was pitched backwards like this one is, if it was strictly a steam radiator with the only passage being on the bottom. Because these last couple sections would flood at the bottom, and I think what would happen is, well, it would prevent steam from entering the radiator, okay? It would act as a water seal here. So the initial steam when the system is first starting up, okay, assuming the system is like correctly sized, right? When the steam's first starting up in a correctly sized system, the pressure is very low. It's like 1/2 inch to 1 inch of water column, which is like 1/50th to 1/25th of a PSI. And under those conditions, this radiator would stay stone cold. I'm talking about if it was a steam radiator that was pitched heavily in the wrong direction, like how this one is. Because the only way for the steam to get in is for the air to get out. And the only way for the air to get out is to get pushed along the bottom and to go up and out the vent. But with the bottom flooded here, there's at least an inch or two of water seal. And that's going to require an inch or two of pressure to start pushing it out. So let's say on a long call for heat, this radiator is going to be cold in the beginning, I believe, if it was put in the wrong direction and if it was flooded out. Then, when the other radiators start to fill with steam and their vents start to close and the pressure starts to build in the system, once it gets to a few inches of water column, or if the system is oversized like so many of them are, this would happen even a little quicker than that. Then there's going to be pressure here, and it's going to push steam through this flooded out bottom portion. And that's going to result in the same kind of hammer that we heard in this bucket. Right? So does this mean I'm going to have to go find a small radiator that's a steam radiator on Facebook Marketplace now and buy it and somehow lift it up on my rig here This one's heavy enough. It's little, but I'm going to have to find a steam radiator to tip the wrong direction. But right now, that's my thought experiment as to what would happen. So I got to walk this back a little bit. I said it's no big deal. I still say it's no big deal if the radiator is anywhere close to level. But if the radiator is pitched crazy like this one is, in the wrong direction, and if it's a steam radiator, and if it's a one-pipe scenario, I'm thinking, yeah, because if it's a two-pipe, it's going to have this top passageway, right, like this one had. So if it's a one-pipe radiator, and it's a steam radiator with only a passageway on the bottom, and it's tipped heavily in the wrong direction, then yes, I could see it causing, number one, a cold radiator at the beginning of a call for heat. But then as the steam pushes its way through that water seal at the bottom, it could cause banging, okay? So unfortunately, this is not a steam radiator. This is a water radiator. This is all you can buy now, at least easily around here in New Jersey. This is, if you go to like Wallingford, or is that the name of it, or one of the other supply houses, this is what you get. And you know, it'll work, but it's not going to provide me my experiment that I need for this. I bought this radiator some years ago to replace one that had rusted out, and it was too small to replace that one. So I ended up, you know, putting it into storage, and now I'm using it for this experiment. But there you go. So I'm walking it back a little bit. I think in a steam only radiator situation, in a one pipe scenario, tilted with an inch or more in the wrong direction, then yes, you could have an issue. But it would have to be really heavily tipped. I think if it's anything close to flat, you're fine. It doesn't have to tip toward the valve. And it's hard to make it tip toward the valve sometimes. You've seen these pictures where they put some checkers underneath this far side, right, in an effort to change the angle. But this pipe is so fixed in its angle, typically it's rusted all to hell. You're not gonna, by raising this end of the radiator, it's not gonna actually allow you to change the pitch. A lot of times what it does is it just raises the whole radiator up so that this leg is like floating in the air. We've seen that, and I've seen that with my own radiators. You can't adjust the pitch very much unless you're putting them in from scratch and you have control over the run out geometry. So, all right, that's that. There you go. Well, I don't know if this is a washout, but that's what this video is. Thank you.